Hey all, welcome to the Algebra Help Board. Thanks for posting all your problems and thanks for watching this. So let's get started. Lesson 75. We have quite a few problems to do. The first one is a distance problem, which I'm not surprised about. I'm only going to do one of these. So if this is your area of problem, pay attention. So 75 number 1 says David traveled 120 miles in 1 hour less than it took Emily to travel 360 miles. Emily could do this because she drove twice as fast as David. Find the rates and times of both. Okay, I'll get you set up on these. This is lesson 75 number 1. This has two different distances. These are newer problems. So number 1, we have two different distances. That's how you know you're going to draw two different pictures. When the distances are the same, those are equal distance problems. So we have the distance of David and we have the distance of Emily. David's distance is 120. Emily's distance is 360. So we're going to write two different distance equations. Remember, distance equals rate times time. So rate David, time David equals 120. Rate Emily, time Emily equals 360. Don't these look familiar? These are the kind of problems where the miracle happens. Remember those? So we need a couple more pieces of information. I'm going with, it says that Emily could do this because she drove twice as fast as David. So of course girls always go faster in the Saxon books. So the rate Emily is 2 times the rate of David. The other piece is with the time. It said it took in 1 hour less than it took Emily. So David drove 1 hour less than Emily. Now, do you see how I have the E here, the rate Emily? I'm going to put the other one, I'm going to put the time Emily and work from there so that we have both of these start with subscripts of E so that we can put them in this equation right here. So what am I going to do here? It says that David was 1 hour less than Emily. That means Emily's going to be 1 hour more. So it's going to be time David plus 1. Now I specifically did that. You could have said time Emily minus 1 equals time David and then solved it for the time of Emily. But you need to have these subscripted with the E's written down, ready to substitute in. So now we've done these before. These are just substitution problems. I'm going to substitute it. I'm not going to do the whole thing, but I'm going to substitute the R, 2R sub D up here for RE. So we get 2R sub D. The rate of the time of Emily is TD plus 1, and that's going to equal 360. I'll go another step. So we're going to get 2RD TD plus 2RD. I'm distributing that through, I forgot the 2. 2RD equals 360. And then, you know, remember the miracle part? This is RDTD. It equals 120. You're going to put the 120 in there, and then you can solve it from there, I'm pretty sure. Okay, next problem was, let me just check. We did 1. Let's go to 9. So 9 is one of these radical problems. 3 root 3. Someone put one of these on later. I'm only going to do this one because this one's definitely harder than the other one. Anyway, so we multiply the numerator and the denominator by the conjugate, which is the same as the denominator, except you're going to change that connecting sign. Now you have a binomial times a binomial. Same in the denominator, you have to FOIL. It's a little tricky. So we're going to do our first, we get 6. Our outer is going to be 4 root 12. The inner is going to be minus 9 root 3. And the last is going to be a negative 6 root 36. All over, I didn't leave much room, did I? First would be 9. Now the beauty of multiplying by a conjugate is that the outer and inner will add out. So we just need to do the last, which is going to be minus 4 times 12, because square root of 12 times square root of 12 is just 12. Now we no longer have a radical in the denominator, which is an illegal thing, and we got rid of it. So we're just going to simplify this out a little bit. 12 is going to be the square root of 4 times the square root of 3, right? Or you could tree it out. This is just going to be 6. So let's just simplify this out. We're going to have 6 plus the square root of 4 is 2. So it's going to be 8 root 3 minus 9 root 3 minus 36, all over negative 39. And so your final answer, you add the number parts together, you're going to get negative 30 minus root 3 over, actually it's not the final answer, it's just not good to have all those negatives. We'll multiply the top and the bottom by negative 1 and we get 3 plus root 3 over 39. That was cool. Okay, next one. We are on number 11, 7511. Oh, this is a blob problem. Blobs, blobs. Okay, so we have our blobs. I'm just going to look, I drew a line through my blobs and I have 2 points. These are my 2 points. We did these in class. Someday, maybe you'll learn to love these. I don't know. So here's my 2 points, 97, 24. I just tried to draw the line through them. If we subtract the y coordinates, I'm going to get a negative 3 on the top, and 97 minus 95 is going to be a 2. So my slope of my predicted line is negative 1.5. Sometimes I have a delay in my pen. Okay, hold on a second, still delayed. Okay, so we're going to take our y equals mx plus b, right? And we're going to put in the x and y coordinates. So I'm going to put in the 27. I'm going to put in the negative 1.5. The x is 95 plus b. When I do all that work, I get b equals 169. The book is a different number. I told you it's going to be off a little bit. You just need to make sure if it's positive and not negative. Like if it makes sense, then you're going to use it. And then you would put in, when you're putting this back in, you would use the right letters. So it's in the y coordinate is v, so it would be v equals negative 1.5 at, the letter is p, and then it would be plus 169. It's a little off, but we're going to go with it. Alrighty, let's go to the next one. We have 111, we're on 15. A little painful, but we're going to press through this. All right, 15 is, we're going to use the quadratic formula. It's negative 2x plus 4 equals negative 5x squared. There's another one of these. I'm only going to do this one because it's way harder than the other one. So you always have to set these equal to 0. So you get 5x squared minus 2x plus 4 equals 0. Then you say a is 5, b is negative 2, and c is 4. Has to be set equal to 0 and in descending order of variables. Then we pull our quadratic formula, which we all know. So it's x equals negative b, so it's already negative, so it's going to be plus 2, plus or minus the square root of b squared, so it's going to be negative 2 squared, so it's going to be 4, minus 4 times a times c, so it's going to be times 20. A times c is 20. 4 times 5 over 2a, which is going to end up being 10. All right, so we're going to simplify this, and we're going to get x equals 2, plus or minus, you just pop this all in your calculator, and you get negative 76 over 10. You can't leave it like that. The temptation's to walk away, right? But we do the tree with 76, and guess what? We get 2 plus or minus, a 2 comes out, and we're left with a 19. If you did the tree, you would have 2 2s, you would circle them, and they would come out. You're left with a 19. I pop my eye out over 10. Finally, it's still not done because it needs to be reduced. We can take a 2 into this, a 2 into this, and a 2 into this. It has to go into all 3 of these in order to cross them out. So your final answer is 1 plus or minus the square root of 19i over 5. That one's a little bit more work. The other one is not that much work. It's not a lot of simplifying. So hopefully that was helpful in understanding how to use the quadratic formula. Okay, next one. Going back up here. That was 15. Let's do 19. 19, right here, lesson 75, 19. It's 2 plus I times I minus 4 minus the square root of negative 16. A lot of I stuff here. We're going to use the FOIL first. First is 2I. First, the outer is negative 4I. Whoops, no it isn't. The outer is negative 8. The inner is plus 1I, and the last is negative 4I. And this is going to be a negative. The square root of 16 is 4, but we had to pop our I out. So we got that. I forgot the I squared somewhere. First, outer, inner is I squared. This 1 threw me because it looks like a 1. So let me just check myself again. First, outer, inner, last. Okay. This little I does not look like an I. Okay, so we are going to get, let's underline all our I's. So we have 2I minus 4I is negative 6I. I squared is equal to negative 1, so we'll just have that, and we're going to get minus 9. You should put it in the right form. The real number comes first, and then the imaginary. This is a complex number in the right form, a plus bi, and that is your final answer. Okay, and let's see, we had 17. Use triangles. Let's do Chad's number 17. Here we go. We have triangles. So here's our triangle. I actually looked in here early before Chad got his in and already started these. So if you can get them in before 11, that would be really helpful because I have to be somewhere at 1:30. All right, so we have x, 60, 8y, and then we need to do, it says use similar triangles. So if this is a 30, because this is a right angle, so that would mean this one has to be 30. 90, 60, you have to memorize this. The one opposite the 30 is 1. The opposite, the right angle is 2, it's the biggest, and then the square root of 3 is the middle one. If you put it in a calculator, it would be between 1 and 2. So you use this, just do similar triangles. I'm not going to do all of it. You go left to right, 8 over the square root of 3 equals x over 2. And then you would do 8 over the square root of 3 equals y over 1, which, that would just be the answer. But you would actually take that back. You have to rationalize these. So make sure you don't leave a radical in the denominator. It's going to be 16 equals the square root of 3x, and then divide by the square root of 3. It's a little piece of work, isn't it? So you get 8. So y equals 8 over root 3. Rationalize. You have to take top and bottom by the square root of 3. I said I wasn't going to do this, but I did. Equals 8 root 3 over 3. And then x, you have to rationalize this, such as this. Did I get that right? So we're going to get 16 root 3 over 3 equals x. I think those are right. All right, that's how you do that one. Okay, next we have, let's see what I did so far. So I did 198. Chad has 23 snuck in there. All right, let's hit 23. So these are tricky. They come up a lot. Everyone's slightly different, which is what makes it hard. And where is that 3? Sometimes you can't tell, but it's on the seat. So we're going to put parentheses where the radicals are. So it's going to be 2 times 2 to the 1/3 power. If it's on the seat, it goes on the bottom. This is a square root, so the 2 is going to go on the seat. Now, here's the tricky part. This 4 is not an index. It's a whole number in front. But do you see how everything else is written with 2's as bases? We want to make everything have a 2 as a base. That's going to change everything. So we're going to get 2 squared, and then this is going to be 2 to the 3/4 to the 1/2 power. Just keep it going here. So we're going to get 2 squared, and then that's going to be times 2. Look at this. Okay, I think something went wrong here. Let's see. What did I do? Oh, this should have been 3 on the bottom. Yeah. Because it's 4/3, not 4/2. Okay, so then we're going to get 2/3. And then we just have to add those exponents. So this is going to be 6, 7, 8/3. And that's your final answer. A little tricky. Try to get all the bases the same before you start, because you can't add the exponents unless the bases are the same. And finally, are we on a finally? Yep, 27 for this lesson. 27. Oh, you know what I said on this one? This is use your calculator. If you want help with this, ask me in class or Google how to do scientific notation on a calculator. There's the Y to the X button, and I'm going to have to show you that one. So Shannon, I'll show you that one in class. If we might end a few minutes early, hopefully. Okay, let's go to lesson 76. So 76A. Okay, I'm only going to do one of these, so pay attention because we had a couple people ask for more than one of these. So this is lesson 76A, and it is x equals 3y. These are not bad. Don't let them freak you out. Equals 56. They get harder. X minus 2y minus 3z equals negative 25. If you don't get a whole number answer, you probably did something wrong, or an integer answer. So x equals 3y. They give you this little baby equation. So we're going to put the 3y in where the x's are. And that way we only have two variables and two equations. Because we're going to have 3y plus y plus z equals 56. 3y minus 2y minus 3z equals negative 25. We're going to combine our y's, and we're going to get 4y plus z equals 56, and y minus 3z equals negative 25. Now to eliminate, we're going to take this top equation by a 3, and then we have a 3z and a negative 3z. So we're going to get 12y plus 3z equals 168. Y minus 3z equals negative 25. When we add those, we're going to get 13y. The z's add out equals 143, and you get y equals 11. Then you go back and find the other variables. So you go back and you put this y as 11 up here. So you're going to get x equals 33. And then you put your 11 and your 33 in here, and you solve for z, and you get z equals 12. You should write this as an ordered triplet with x in alphabetical order. So we get 33, 11, 12. There you go. Okay, one down. Number 1. Another distance problem. I'm not sure if I decided to do one or not. I think I didn't do this one because it is the same as the one that I just did. So this is a, let's see, 32 miles and 72 miles. This is exactly like the one that I did from lesson 75. So moving on, we have number 2 is the P1 V1 over T1 equals P2 V2 over T2. And you're supposed to begin by solving for V2. So I'm going to multiply both sides by T2. So P1 V1 T2 over T1 equals P2 V2. And I'm going to divide by the P2, and we get V2. All right, so what would the final, it says the initial pressure, volume, and temperature were blank, blank, blank. What would be the final volume if the pressure was changed to blank, blank? So, Chad, just substitute them in. You might have just made a silly mistake on your computations. So that one takes a lot of time for me to do. Let me know if you still need this in class. Okay, and number 4. This one's a little bit on the stranger side, so let's just set this one up. Number 4, we have Na, Cl, and O. They're each 1, so you're going to take 1 times what Na weighs. It's going to be 23. 1 times Cl, which is 35. 1 times oxygen, which is 16. They're telling us that they had 280 grams of chlorine. 280. We need to find this total down here. They want to know what this one is and this one is. Once we find the total, we're going to subtract the 280 and it'll tell you what these two are. So I don't know where I wrote this. Here we go. So we're going to add this up. So this is going to be 74. We're just going to do a little proportion. We're going to do 35 over 74 equals 280 over x. You're going to cross multiply and you get x equals 592. So right down here, this is 592. If you subtract 280 from it, you're going to get 312, and that's how much the sodium and the oxygen are going to weigh. And that is that. Okay, these are combined. You don't have to find them individually. That's what might be confusing about that problem. So next one, we are in 76. We are making our way down. We did 2, 4, A, and 1 so far. So let's move to 6. 6. Okay, Ashley, this is the one like I just did. You just want to replace the x's with 2y and solve by elimination. So 14. Oh, I'd love to do this one for you. Thanks for asking. It says begin with ax squared plus bx plus c. Every once in a while this shows up on a test. I don't know if it's a test I'm going to give you, but of course you would have the study sheet. You want to derive the quadratic formula, which means you're going to solve this for x. The quadratic formula is just a way to solve for x without factoring or completing the square or anything. So we're going to just complete the square and get the formula. So remember, to complete the square, we have to divide everything by the coefficient of the x squared term. So we're going to get x squared plus b over ax plus c over a. You know what? I'm going to move that onto the other side just to try to save a little bit of time. So it's going to be minus c over a plus your blank. What do you fill your blank in? Well, you divide this b over a by 2, which is the same as multiplying by a half, and then we square it. And so it's going to be b squared over 4a squared. We're going to do the same thing to this side. What we formed is what we call a perfect square trinomial, so it factors into x plus b over 2a quantity squared. And on the right side, we're going to find the common denominator, which is 4a squared. And this one needs an a, right? So it's going to be negative 4a needs an a, and it already has a c. This one doesn't need anything, plus b squared. Alrighty, now we're going to take the square root of both sides. The plus or minus square root of both sides, no less, because that's what you do. You need two solutions. So we're going to get x plus b over 2a equals plus or minus. I am just going to rearrange this and put the positive one first, because I know where I'm going as well. Square root of 4 is 2, square root of a squared is a. Now all we're going to do is bring this guy to the other side. We're going to put it all over 2a because they have the same denominator. So we get negative b plus or minus the square root of b squared minus 4ac. Wow. Okay, and that's the quadratic formula. So then anytime you have a quadratic equation, you can just put your a, b, and c in, and out will pop the x. It's not as simple as it seems, but that does work. Okay, moving along. Time is running away quickly on me here. So we're on 76. That was 14. Let's move to 18. Okay, this is a little fun one. 18, I haven't done these in a while, plus a over a plus a over x. So I'm going to deal with this complex fraction by multiplying everything top and bottom by an x. Watch how cute this is. So we get ax, and then we're going to get ax plus, these x's are going to cross out, and we're going to get an a. Then we find a common denominator because we have two fractions. This one is a 1. Our common denominator is ax plus a. This one needs the whole ax plus a, and this one needs nothing. Alrighty, distribute that through. This one's a little complicated, that's why I'm doing it. Ax squared plus ax and plus another ax, all over ax plus a. So let's just put all the steps in here. We get ax squared plus 2ax over ax plus a. If you'll notice, there's an a in every single term. So we can factor an a out of the top and out of the bottom and cross it out. So I'm going to just slide over here because I'm out of room. X squared plus 2x all over a times x plus 1. The a's cross out, so our final answer is x squared plus 2x over x plus 1. A little complicated because you have to factor the a out because it's in every single term. Okay, and we have one last one for this one, which is number 22. Let me see what it is. Okay, Chad, I'll do this one for you. I wasn't going to, but I know. So we have 5, and it's 25 root 5. Okay, same thing. Get all the bases the same. Parenthesize the ones with radicals, which isn't really a word. So, but 25 is 5 squared, right? And this is going to be 5 to the 1/2 power to the 1/2 power. So we do inside the parentheses add the exponent. So it's going to be 5 to the 5/2 to the 1/2. And then we just multiply the exponents because they're power to power. So it's 5 times 5 to the 5/4, and this is 1, so we're going to add our exponents. It's going to be 4. It's going to be 9/4, I hope. Okay, onward, lesson 77. Righto, did I get them all? Okay, 77, let's start with number 3. All right, we have a mixture problem. I love mixture problems. Why don't you guys like mixture problems? So here we go. We have buckets. Actually, I call them bucket problems, right? We got some buckets. We are going to help somebody out here. The drink was cloying, whatever that means, because it was 30% sugar. So here's the 30%. How much was the drink? There's 50 liters. How much do we have to add to it? How much water do we have to add? Well, this is 30%. This is 30% sugar. How much sugar is in water that we're adding? There's 0. So there's 0% sugar to get a solution that is 3% sugar. And what's in the bucket? Well, there's whatever's in bucket number 2 plus what's in bucket number 1. Okay, so we multiply. There's one variable. We need one equation. So it's going to be 30 times 50. That is 0. That makes it easy. So we're going to get 3x plus 150. And when we solve this, we get, I did this problem somewhere. Hold on a second. I don't know where I did it. Now I have to do it. So we're going to get 1,500 equals 3x plus 150. We're going to take 1,500, subtract 150, divide by 3, and we get 450 liters. There you go. Okay. 3. Let's go on to number, wow, we jumped to 11. Amazing. Okay, 11. 11, oh my, we're going to add these vectors. Okay, guys, calculator problem all the way. Plus 6 at negative 200 degrees. You just put this in the calculator. I'm not even going to, let's see, I put the answer somewhere. Here we go. So for the x, we're going to do negative 4. Remember, x goes with cosine of 30 degrees. Plus 6 cosine of negative 200 degrees. And then y is going to be negative 4 sine of 30 degrees plus 6 sine of negative 200 degrees. I just go the whole way across in my calculator and I get the answer x equals negative 9.10. X is your right. If you put all the y's in your calculator, you get 4.05 up. Man, I did that one fast. Okay. Number 19. 19 is, oh, I hate these. You guys keep putting these up every week. I don't hate them. I mean, it's not like they're that difficult, but I feel like I do these all the time. Equals 10, and then we have I'm going to do this really quickly. Minus 0.2y equals negative 1.58. All you have to do is get rid of your fractions and decimals. I'm going to multiply this whole equation by 35 because it's a common denominator. 7 goes into 35. 5 times 5 times 3 is 15x. 5 goes into 35. 7 times 7 times 2 is 14y. And 35 times 10 is really nice, 350. This one, everyone goes over 2. So we get 3x minus 20y equals 158. what I did was I multiplied this one by a -5, added them together, and got my y. And I'm not going to finish this one because it's pretty simple. You eliminate your y's. Actually, I eliminated the x's, and I got y equals 10 and x equals 14. All right, 19, we are on 21. 21 is solve by completing the square. I'm not going to do this one because it's really straightforward. You are just setting it equal to 0. So you're going to get 2x squared plus 7x minus 1. Make sure you get your a is 2, your b is 7, your c is -1. Plug it into your formula. It works out really nice because there's no imaginary numbers and there's nothing to simplify. So that one's pretty easy. Saving time not doing that one. Okay, 23. Okay, a circle is inscribed in a square. Okay, this one's not as bad as it looks. Here's our square. I don't know if I can inscribe a circle into it. You know, I can't. All right, let me just draw it. Then, I don't know what'll be worse, but I can't. My tool won't work. So you got a circle. Yeah, this isn't good, but all right. So it says that the area is 4. So a square is side times side. So both sides need to be 2 in order for the area to be 4. So that's the first one. The side is 2. You have to get the unit centimeters. Okay, now we need a diagonal. Diagonal, we have a square. A square is 2 and 2. All I did for the diagonal was to do the Pythagorean theorem. So 2 squared plus 2 squared equals 8, right? I mean, whatever. And so c squared. And so we get c squared equals 8, and you have to simplify it, so you get c equals 2 root 2. And the final question is, what is the radius? This is going to be in centimeters. The radius is just going to be from the center to the top. Well, if the side is 2, the radius is just going to be 1. So the radius is going to equal 1 centimeter. All right, not as bad as it looked. And our last one is number 25. It's another one of these guys. These keep coming up. I don't know what it is. Make sure you're paying attention here. So we're going to put it to the 4th power. I'm just skipping around a little bit. It's 4, so I'm going to make it 2 squared, and then this is going to be 2 to the 1/3 power. Deal inside. I just take 3 times 2 is 6 plus 1 is 7. So it's 2 7/3 to the 1/4, and then you're going to get 2 to the 7/12. The end. And we are done with lesson 77. Awesome. Okay, let's go to 78. Lesson 78. Ooh, we got a lot of them here. Okay, let's see how many we're going to do. Lesson 78A we have to do because it's a new problem and I didn't even have time to go over this in class. So let's hit it. 78A. So we have 2 vectors pulling on a point. So here we go. We have a point right here. We'll just have this point. We have one going this direction, and that does not look like 22 degrees. Whatever 22 degrees is, it's pretty small, right? So this is 22 degrees, and it is 30. And then we have another one going at 58 degrees, 58 degrees, and it is 40. Okay, these are our vectors pulling. So what you have to do is turn it into rectangular coordinates, which we should be pretty good at. So we have one pulling, the x direction is pulling negative, right? This one's going negative. So the x one, this is like that other one that I did, it's just going to be 40 cosine of 50 degrees. This is going to be negative because it's pulling in the negative direction. So we're going to do negative 40. It's pulling in negative in the x direction. Plus 30 of 22 degrees. You just pop that in your calculator. This one's pulling right, which is positive. This one's pulling left. It's negative. That's why I put the negative 40. When you put in your calculator, you get 6.62. Then we do the y's. They're both pulling up, so they're going to be positive. So you're going to do 40 sine of 50 plus 30 sine of 30, oops, of 22. And so for this one, you're going to get 45.16. They want this actually to be in polar coordinates, So we need to put them into polar coordinates. I think I'm out of room this way, so I'm going to go upwards, okay? So if I plotted these real quick, what would they look like? They're both positive. So to the left, we would only go 6, and up we would go 45. So it's going to be a much steeper triangle than this, but I'm just doing a random triangle. This side, your x was 6.62, right? And your y was 45.16. I just did the Pythagorean theorem in my calculator, did this squared plus this squared, and then I put second square root, second answer, and I got the answer for my hypotenuse, which was 45.64. Then you need to find theta. To find theta, you do the inverse tangent. Inverse tangents give you angles of opposite, which is 45.16 over adjacent. You push those buttons and you get theta equals 81.66. Write it in polar form, so you'd write 45.64 at 81.66 degrees. A little challenging, nothing new really, just make sure if it's pulling to the left you use a negative vector. Okay, so we did A. Yikes. Alrighty. Number 6. I have 5 more minutes. 6 snuck in there. I don't have that one ready. So the quotient of two numbers was 2. So the two numbers, so you have n over d. That's the quotient. Their product was, the quotient, let's say, was 2. And the product n times d equals 200. So you just need to solve this for d, just solve, cross multiply, get n equals 2d, and then put that in right there, and then solve it. All right, time. Okay, 6, 12. 12 is another vector problem. It's a little bit more complicated, but not as complicated. So we have a vector pulling this direction. It's at 27 degrees. It's 10 units long. And then we have one going straight up, 8. So this one's actually a little bit easier. To do your x, you do 10 cosine of 27 degrees. And to get your y, you say equals 10 sine of 27 degrees. You're going to get, for this one, you get 8.91 right. For this one, you get 4.54 up. This one right here only has an up. This is just 8 up. So y equals 8 up. There's no x. So you add it to that one, and you're going to get 12.54 up. And then you have to make your triangle and do what I did before, Pythagorean theorem, and then you're going to use the inverse tangent. All right, now I have to pick and choose which ones I can do. That was 12, 22. 22 is use similar triangles. I did one of these, so I think you can hit that one. 24 is one of those ones that I've done 100 times with the radicals. And number 30, I'll do that one and then we'll end. So 30 looks like this. Oops, hold on. It's not playing with me right. Okay, here we go. All right, so you have your angles S, you got this, and you got this, and V, and U, and T. These are similar triangles because you have 2 angles in one triangle can grow into 2 in the other because these are vertical angles. So you can write a proportion. You have to kind of flip this up around, and so you're going to get S over T equals, we're going left to right, U over V. They want you to solve that in terms of S. So we're just going to cross multiply and get S equals UT over V. And that's it. That's what it means to solve in terms of. You leave the other variables in the answer. Okay, that was we did that pretty quickly. I think I covered just about everything. I feel bad about 24. I'm just going to throw 24 in because it's a little bit challenging. 24 is 2, it's the 5th root of 4 to the 6th root 2. All right, so you're going to do 2. This is going to be to the 1/5 power. Just want to show you something. 4 is 2 squared, right? So it's 2 squared to the 6th, and this is going to be 2 to the 1/2. So everything's the same except this is going to be actually a 12. So it's going to be 24, 25, 25 halves to the 1/5. And then I'm assuming you guys can take it from there. All right, that's it. And we'll see you in class tomorrow. I started a new Google Classroom thing to communicate. So if you got the email, accept it and go in and you can see your assignment, and we'll be building on that later.